Welcome back, AP Psychers, and hello, Darby. This is Darby. Some of you have wanted to see what Darby looks like, my cat. We're about 15 minutes away from his feeding time. He's on a very strict, fixed interval schedule of reinforcement. Anyway, in today's video, we are going to be talking about the FRQ that was assigned yesterday. The first FRQ bullet in the practice research method FRQ was to operationally define the dependent variable. This is a skill that we must master. It's a skill that we've been practicing all year, and it is a skill that we will certainly continue to practice in anticipation of the AP exam. Let's use the format that we described in a previous video. Let's take the scenario and put it into an if-then format. If you can take the study and put it into an if-then format, you can then easily definitively determine what the dependent variable happened to be. In the study that you took a look at, it asked you to evaluate whether or not seeing a large or small bowl would increase the quantity of food that a participant actually ate. So if you see a large bowl, then you will eat more food. That's a sample hypothesis. Unlike the Halloween prompt that you saw a few days ago, they didn't definitively give you the hypothesis. However, we can very quickly look at this scenario and come up with a simple hypothesis. If you see a large bowl, then you're going to eat more candy. And that's actually what the table, which we talk about in just a little bit, seems to illustrate. Again, after the if is always the independent variable. We're doing the double I mnemonic here, which would then mean after the then, you have the dependent variable. So in this circumstance, we're going to be isolating eating. However, it asks you to operationally define, which again means to give the most precise definition possible and specifically identify how it is measured. If you look at the prompt, it actually uses the word measured, and it specifically says the weight of food eaten. So one way to answer this bullet in just one single sentence would be, quite frankly, to find the word measured in the prompt, which in this circumstance is in the last paragraph, and basically just copy the remaining portion of that sentence, leaving you with the answer. The operational definition of the dependent variable was the weight of food that each participant took regarding how much they actually ate. The second bullet asked you to calculate the median of specifically the large bowl column. This is not a type of bullet that we've seen before, though you've seen plenty of multiple choice questions where it asks you to calculate median or mode. Not as frequently mean. Mean is a more challenging one. Anyway, whether it's median, mean, or mode, they are all examples of central tendency. The median, which is being asked about here, mean or the average, and then mode, the most frequently occurring score in the set or distribution. To calculate the median, it's really quick and easy. You just rearrange the numbers. I like to do it in descending order, but it really doesn't matter. Then you cross out the top and bottom number again and again until you get the middle number, which in this case is 387. So the median for the second bullet is 387. The third bullet asked you to describe the technique that was used to determine groups in this experiment. It's about a topic that we've described numerous times throughout the course. It, however, was presented in a slightly different way, which is why I asked you to take a look at the question. In order to make groups in an experiment, you use, of course, what we call random assignment. To score that bullet, really all you had to do was say the process of random assignment was used to make groups. That would simply score in one sentence. If you would like to go a little bit further, the precise randomized way to make groups in this particular study was flipping a coin, which is a 50-50 proposition. Gives every participant a totally even 50-50% chance to either go into the large bowl group or the small bowl group. But just to take a few moments to add additional context to random assignment. Let's say there were 1,000 possible people that could be part of your study, but you don't want to actually experiment with 1,000 participants. So that 1,000 people represents your population. In order to proceed onward with your study, you need to do what's called random selection, where you randomly pull out 30 names. So you have a list of 1,000 names. Every single member of the population gets one number associated, number 1, 2, all the way up to 1,000. You randomly pull out 30 of them. So you get numbers 258, 392, 442, number 990, whatever it might be. So now you have 30 people that show up to your lab to be part of your study, to be either intentionally placed into a group where you see a large bowl or intentionally placed into a group that gets a small bowl. But the experimenter, the researcher, cannot in any way, shape, or form manipulate which group a participant is placed into. Instead, we need to use random assignment, where you are placed in either group totally randomly. So this is what I'm writing here, random assignment. So you get randomly assigned into one of the two groups, whether it's the control group, the experimental group. Some studies technically have more than one experimental group, but ultimately you get 15 people here and 15 people here through what's called random assignment. The prompt described flipping a coin. That is a solid, totally reasonable way of doing it. The way that I like, the way that if you were to see an FRQ and it asks you how to randomly assign, what I want you to write is, of course, random group generator. If you are asked how to randomly assign and your answer does not include the word group, there's almost no way it can score. So please encode into your long-term memory random group generator. But make sure that you're describing it at the right phase of research. Random assignment happens here, where you already have just 30 people, and you need to break it up into 15, 15. Random selection is when you pull out a small number from a giant number out of the whole population. This phase is random selection. This part here is random assignment. To go back to the Halloween FRQ from the other day, one of the main shortcomings of that study was that the researcher did not randomly select. She just used members of her community who showed up at her doorstep. That's not random. That does not adequately represent all members of the community and all children across the globe. If you actually want to make a generalized conclusion, a statement that can actually be generalized at the end of your experiment, you need to have a random selection of participants to the best of your ability. Then you need to randomly assign them into it. The fourth bullet takes a look at a point addressed in the video that corresponded to the FRQ today. They were terms that we did briefly talk about in Unit 2, but I think adding some clarity and seeing it in the context of an FRQ could be of a benefit to you. I've recreated, to the best of my ability, the table on the FRQ. Here at the bottom in blue, I have mean, and at the very bottom, I have standard deviation in red. The question asks you to evaluate the variance or the variability of the results. When you see these two terms, there are two possible things to discuss, either range or standard deviation. If you take a look here at the numbers, we can very quickly take 445, which is the highest number, and 258, do some quick math, and we're looking at a range of about 187. Otherwise, we can take a look here at the small group. We can take the biggest number, which is 274, take the smallest number, which is 148, and that would give us a range of 126. So these individual numbers tell us the range. So the large group, it's 187. The small group, it's 126. You could say as an FRQ bullet, the range in the large bowl group was greater than the small bowl group. That is an effective way to describe the variance. We determine variance in one of two ways. We either calculate the range or we take a look at standard deviation. It might not seem like a super complex thing to conclude, but if you quickly calculate the range or even just eyeball it, you can see that the large bowl group has a larger range. The other way is to look at standard deviation. You will never have to calculate standard deviation. It would require a calculator, involve many steps that are way beyond the scope of this class. But when you see the standard deviation, you need to be able to evaluate what that means. So the standard deviation in the large bowl group is 72.6, and in the small bowl group, it's 49.3. The larger the standard deviation, the more spread out the scores happen to be. So you could very easily take a look at these numbers and say, the scores in the large bowl group varied more as shown by the higher standard deviation. Basically, when you see a bullet and it asks you to evaluate variance or variability, it's asking you to determine which group varied more. There were two calculations to determine which group varied more. Range, so you can definitively look at the large bowl group and say, the range in the large bowl group was greater than the small bowl group. That's one way of describing variance. Or you could take a look at standard deviation, which was provided for you. 72.6 is quite a bit greater than 49.3. As a result, you can definitively conclude that the scores in the large bowl group varied more. They were more spread out as a result of just looking at standard deviation. Again, the final point in today's video is to talk about a subject that we spent some great deal of time on back in Unit 2. It's easily one of the most confusing types of bullets that you could encounter, really very well might encounter, if you see a research method FRQ. And that's when it asks you to make a definitive conclusion or an appropriate conclusion about the results. This study that we've been looking at had random assignment. It had a table that definitively broke into groups. It had a table with mean in it. It had a table with standard deviation in it. The study that we've been looking at this whole time is an experiment. When we evaluate an experiment, we can actually use the word cause. It is the only type of study where we can actually use the word cause. So in our answer, we are going to use the word cause. If you were to look at the prompt, it asked, what is the most appropriate conclusion? But right before that, it said, assume all mean differences are significant. That might sound really fancy, wordy, like what exactly does that mean? If you remember back in Unit 2, significance actually means something when looking at the results of research. That means the results were what we call statistically significant. I know it didn't use the word statistically, but just seeing the word significant in the context of an experimental result means statistical significance. What does that actually mean? It means a couple things. It means, one, they calculated P, and P was 5% or below. That aspect of the bullet isn't something you would necessarily need to write, but it's not inconceivable you see that in multiple choice, or you could conceivably see them reference 5% or below in an FRQ prompt. So you wouldn't need to include that in any bullet, but it's definitely a good point to know. But what does it actually mean when the p-value is 5% or below? Well, it means the independent variable did cause the dependent variable to change. You actually proved cause and effect, which is a very important thing to note. So when you see this, when you actually have to write it in an FRQ bullet, this is what I want you to write. And it really, quite frankly, only one sentence. So I'm going to erase right here where it says statistical significance to give us some space. The most appropriate conclusion that can be drawn from this study, looking at the numbers, if you look down at the table, I know I don't have it up here, but I'll project it for you right now. Notice the mean in the large bowl group is quite a bit higher than the small bowl group. You were told that the results were significant. That would then allow you to write the following statements. The presence of a large bowl did cause, again, we are using the word cause. Experiments are designed to show cause and effect. It is the only way we can do that in this course. So the presence of a large bowl did cause the quantity eaten to increase. The hypothesis that we described on the first point today was proven to be true. in a question that asks you to make an appropriate conclusion, if it's about an experiment, which we definitively know because it has random assignment, gave us a mean, gave us a standard deviation, it presented it in a table as we described previously, there were two different groups. Under those circumstances, when it asks you to make an appropriate conclusion, and especially when you see a line like this, assume all mean differences are significant, you would then provide a statement that actually shows the cause and effect relationship.